losing 10%. What happened to you, dude?
Sorry.
This. Do you have coursework?
Yeah.
Did you give it to Sylvia?
Yeah.
Okay. Right. Graphs. Graphs of sine and cosine. I haven't started yet. What?
I know. Well, did we finish the trigonometry equation?
Yeah, now, you're thinking about question 3. They have removed that from the syllabus. That used to be on the syllabus, on the exam, but they've made the trigonometry equations a little bit easier. So I don't expect to see one as difficult as that. That's a bit too difficult. Now, if you want to practice 1 or 2 of them, that's great. But they're too difficult for the exam now. Okay. Graphs of sine and cosine. So the first one we'll graph is y equals sine x. And we'll use degrees or radians. Let's use degrees. Not that it matters too much. So the first thing is that sine is always between 1 and -1. So the graph of sine looks like this. Whoa. That's the sine graph. What you probably already know about these graphs is that they're periodic, meaning they repeat. So after 360, the graph repeats again. And before 360, it's the same graph. And the only difference if you were using radians is that there would be a 2 pi instead. Now there's not much point in drawing a new graph for the next one, cos x, because cos x is nearly the same. The only difference for cos x is it starts on a 1, whereas sine starts in the middle, cos x starts at the 1, goes down, it's at its lowest at 180, and then at its highest at 360. That's still at a 1. So you can see that it actually just looks a lot like the sine, except as if it's been moved a little bit. That's really the only difference between a sine and a cos. Not much of a difference. Okay. Next one now is tan. So in a moment I'll draw tan now once you have this. Okay, can I? Not yet, yes. Scroll down. Lee? Yeah, okay. So now, tan. So the graph for tan is, not tax, tan. The graph for tan is totally different to sine and cos. We'll use degrees again. So that's 180, 360, and that's minus 180, minus 360. The tan graph this is 90, and this is 270, and this is 90, and this is 270. Okay, so what does the tan graph look like? I'll try and draw this in. So at minus 90 and 90 it breaks. This shoots up to infinity and this shoots down to minus infinity. And then the graph starts, it looks the same again at 80. Yeah. So it is at minus infinity here. And then, sorry, I said 80, 180. My 1 is falling off. And the same again at minus 180. And just to help you see, all these breaks happen at, that one happens at 90, and then that one here happens at 270, yeah. And this, where's it gone now? That's 90 there. And then this one again is at 270. So you can see that this repeats. It repeats every 180 degrees. If you think back to the trigonometry equation lesson, you remember the rule that I said for the second answer for tan, it's the answer you get on the calculator plus 180. And this makes sense now from the graph, because, for example, let's say if this is an answer, then if I just move over 180, I can get the same answer again. And if I just go back for one moment to the sine and cos graph, for sine, I said the second answer is 180 minus the first answer. Again, this makes sense. If I look here, if this is the first answer for sine, then 180 minus the first answer, so if I just head to the left from 180, I can get the same answer. And for cos, let's say this is the first answer, and if I do 360 minus this, so that would be there, I can get the second answer. In other words, those rules that I gave you, they come from the graphs. That's how I got them. And to make these graphs, you can just make a table and plot all the values, but that's not how you do it in the exam. You need to learn the shapes. So we have the three shapes, sine, cos and tan. And now what we're going to have a look at is how would I graph something like this. A sine bx plus c plus d, or nearly the same, A sine bx plus c plus d. The only difference between the two is in this one the b is on the outside of the x plus c, and in this one the b is only on the x. That's actually an important difference because this one is actually easier to do. And it's easy to change this back into this, because you can just take out that b. We'll have a look now at this. Okay. Let's look at what each one does one by one. So what is the effect of the A? So if I have a graph, like sine, or cos, it doesn't matter, or tan, what would the A do to the graph? That's a 1, that's a minus 1. How would, if I had an A, yeah, what would it do? How would you describe that? Yeah, change it how exactly? What verb would you use? Not clear enough verb. I know what you mean, but we need a more precise verb. Exactly how will it increase? No, you need a noun now. You need more words, please. How does it increase by a? In what way? Multiply by a. That's the key, because you could have added a. So here, the effect of the a is to stretch the graph out. So now it goes up to a and down to minus a. So in other words, it's expand on the y-axis like this. Stretch it. Okay. What will the b do now? The b. Who knows what the b will do? Yeah, give me the word for this. Yeah, what happens to b? You have words. I've heard you speak English before. I know you can. What will the b do? On long... Nearly. But not actually. Say again? Not this. Different verb. Huh? Rotten. Thank you for giving me a synonym of expand. What I meant by different verb is it doesn't actually expand it. Doesn't broaden it. The effect of the b, anybody? No? Is actually to contract it. So for example, if this one here, a is 2, then it's twice as big. But here, if the b was 2, then it's half as long. That's the effect of the b. You should be writing all of this down now. It's useful to know. Okay. Next one now, the c, which is this c here. Whoops, this c here. Okay, so what's the effect of the c now? Who knows that? Or wants to guess? Good. On the x or the y?
What?
On the x or the y? X. Yeah. And how does it change the position on the x?
This is left or left?
Left. Right. Go on.
Left.
It moves left, correct. So the c actually moves the graph to the left. So for example, if the c was, let's say, I don't know, 40 degrees, then this point here now is minus 40, and this point here will be 320. We'll just I should write down these verbs. This is contract. And this one, is anyone know the verb here? Don't say move. Thank you. There's two verbs you could use. Shift is one. And maybe I'll use the other verb for the next one. No, that's mean. I'll give you both. You can say shift or translate. Okay, and finally, D. So, Jerry, you're on a roll. What does the D do? What's the verb? Yep, translate on X or Y. By how much?
How much is that?
By D. Up or down?
Up.
Correct, yeah. So, it moves the graph up. So for example, if the D is 1, then it moves it up 1 unit. Now what we'll do next is we'll put all this together to make one complicated graph. Let's get one. No, wrong program. Okay. Can I scroll down? Bruce? Okay. How much are you writing, Bruce? Which part are you on?
Finished.
Finished? Great. Let's have a look. Alright, let's try something like this. Graph, we'll say, oh yeah, sorry. One other thing I forgot to say. If the A is a minus, do you know what happens? Yeah, the graph gets turned upside down. So the graph goes like this. And if the B is a minus, yeah, it gets turned around like this. So that's kind of hang on. I'll get this, just let me draw a bit more. Okay, so that flips around, so it'll go, it actually, for this particular one, it looks the same when you flip it around that way. If you just took the picture and spun it around. Okay, anyway, let's do something like graph y equals 3 cos x minus pi over 2 plus 2. Now before I graph this is quite a common question on the exam. I've seen it asked a few times. They only want a sketch, but they want an accurate sketch. They want to see all the information on it, like the height, where it starts, all of this stuff. So the way I'm going to show you now is the way you should do it in the exam, and we'll make x go between minus 2 pi and 2 pi. So we'll make it quite a large range to draw as well. Okay. So let's have a look at the steps. So the very first thing you should do is rewrite this as y equals 3 cos 1 x minus pi over 2 plus 2. So, for example, if there was a number here, we should take it out. Now, in this example here, the number is 1, so that's easy to take out. So, first is to factor out any number here. This example, well, you know what, maybe I'll change to make it a bit harder. Yeah, difficult is good. Let's make it more difficult. Let's make this actually a 2. So this becomes a 2, and then what happens here? Over 4, yeah. Okay, so it's still the same deal. Factor out. Okay, so that's step 1. Okay. So the next thing to do, we'll draw our graph. Let's give ourselves enough space. Now I need to be big enough. Oh, will do. Don't forget to write your x and your y. Now we need to go up to 2 pi and minus 2 pi. So let's mark that here. So if that's 2 pi, then that's pi. Then that's minus 2 pi. That's minus pi. Yeah? So this would be like 360. And this is like 180. This is like 90 and 270. 90 and 270. Okay. So now, part 3 is to get the A. Here the A is 3. Yeah. So that means we know how tall it is and how short it is. Now, I like to keep these things in a table. It makes it a little bit easier to keep track of things. So what I mean by table is like this. Question? Do you need me to scroll down? No? Okay. Min, max, start, end. One, two, three, four. I need 5. 1, 2, 3, 4, 5. Okay. So part 3. If it was just costs, we should have a minimum of -1, a maximum of 1. It should start at 0 and then finish at on the x-axis.
1.
No, on the x-axis. X. It starts at 0 and finishes at 360, or in this example, 2 pi. Okay. Step 4. Let's look at the A. The A is 3. So how would the graph change if the A was 3? Yeah, the minimum and maximum change. So this becomes -3 and 3. Okay. Step 5, 6, and 7. Now, the B. What is the effect of the 2 here? Expand or contract? Contract by half. So this is still -3 and 3, but now this is 0 to pi. It finishes earlier. Okay, now the -pi/4, what's the effect of that? Shifts left or right? To the right, it's the opposite sign. Because earlier I said C makes it move to the left if it's a positive. So if it's a negative, it moves to the right. So the effect is to start at pi/4 and to finish at 5 pi/4. And lastly, the 2. The 2 is to raise it 2 units. So this will be -1, 5. Pi/4, 5 pi/4. Now this is the important result. Because using this we can now make our graph. So, in green, let me just mark off -1. So, hang on, we need to put in 5. So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so -1 to 5. -1. to 5. Okay? And then pi over 4. Pi over 4 is 45 degrees. So if that would be here. And then 5 pi over 4 is a little bit 225 degrees, isn't it? So that would be here. No. Oh. There we go. Okay. Now, we have to very carefully break this box into 4 pieces. So if this is 6 units, then 1, 2, 3 units would be here. Oh! Thanks, Monica. Bum, 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 bum. Sorry, this is positive, so I should have drawn it here. Thank you. Okay. I'm just going to zoom in. Okay, now as I was saying, this is 1, 2, 3, 4. Okay, I need to split this up 1, 2, 3, 4, 5, 6 into 1, 2, there. And then I need to split it down the middle, which would be here. Okay, so after all that, I have this little box like a window. Finally, the last step is I can draw the graph now. Because this is cos, do I start at the top, or the middle, or the bottom? Top. So the graph goes like this. And then what you do is you copy this. So it repeats, and then here we copy it as well. Let's try our best. So it repeats, and then one more. I know this is ugly. Okay, that's what it should look like. Let's check it in the graphing program I have. So that's an ugly one. You should try your best to draw it nicely. But let's have a look at what it looks like. Can you just read out, what was it? Y? Yeah, the very original one. 3 cos 2x minus. Yeah. Minus pi over 2 plus 2. Alright, let's see how close I was. Now I need to go to a 6, so let me just... Okay, right. Hold on. I know what the problem is, maybe. It's my car, I should press this button. Identical. Can't tell the difference. Yeah. Not too bad. Not too bad. So these are a little bit tricky to do, but in the exam they're actually worth a lot. They're worth 5 marks. 5 marks is, it's 1 mark for the shape, 1 mark for the A, the B, the C and the D, for getting each part right. So for example, if you made the graph too high, then you would lose 1 mark. Or if you have it starting at the wrong place, you would lose 1 mark. Or if it's too wide or too small, you'd lose 1 mark. So it's 5 marks. Oh, and if your graph was a sine instead of a cos, that's 1 mark. So, in the exam it's like this usually. 1 if you get the sine or the cos part right, and then another mark for getting the A right, the B, the C and the D. So usually 5 marks in the exam. Okay, so you can draw this, or that's what it looks like nicely. In the exam, to zoom out for this one. For what part? Oh no, you don't need that. You should do the green in pencil and the red in pen, and then afterwards you can remove the pencil part, because you are only using that to help you draw it. Okay, so this one can be in pencil. It's only to help you. And then in pen, this is the answer. And also, actually, let's just check this here. So I think if I just switch for a second here, I was showing you about this website. I think I showed you this website near the start of the year. So if you need a little help with these questions, you can just type what you want to do in this. And there we go. We can get the graph here. And maybe we could even say from minus 2 pi to 2 pi. Let's see. There we go. Can you see that? Yeah. So if you need a little help with these questions, you can use this website. And I want you doing these for a few minutes, and then after you try 1 or 2 of them, we'll take a break, okay? And if you need a little help, you can use this website. I think I told you this one. So I'll have you try. I want you to do a sine and a cos. You can try a tan, but they never ask tan in the exam because it's difficult. So I'll have you just try sine, cos, and you can try a tan. So if you can do, let's see. Yeah, ABE. ABE. Try 1A, 1B, 1E. And also, you can check your answer. You can check your answer on the back, or you can also use this website to help you graph. Wolfram, yeah. Okay, can you try making those 3 graphs now, please? So, let's see. We've got no Yash, no Dhruv. We got Fahad? No. Okay. And no Sean.
Why should I have that?
He's cold. Or he has a cold. That's better. Who else are we missing from engineering? No one. No one. And who else are we missing from business? Just the three boys? Alvin? Is he at GMIB? Okay. Who? Oh yeah, 20. Maybe they're finishing their coursework. If you can just wake him up and tell him to do 3 questions. 3 questions, please. Yes. Which limits? At the start? For the first row? Yeah, it's for sine and cos, it's always minus 1 to 1 and 0 to 360. This is a fact for sine and cos. Yeah? What are you asking me? Like,
how did you know?
Are you talking about how did I know this? All of them? Yeah. This one I knew as a fact from what I did at the start. Minus 1 to 1, 0 to 360, okay? And then, as I moved down, I was moving across here, looking at the A, the B, the C, and the D, and the how it affects this. So first I looked at the A. The tree changes these, and I said that here, that the effect of the A is to make it bigger this way. And I continued down looking at A, B, C and D until I get here which is the important one because this helps me make the graph. Yeah? You look so sad.
Where did you get 5? The 2.
This 5?
Yeah.
That's when I looked at the D. The plus 2 moves the graph up 2 units. So here, look, this was minus 3 to 3 here, and then plus 2 brings it to minus 1 and 5. Yeah? This is because of A, because of B, because of C, and because of D. Okay, take a break for a few minutes then. To go what? To print? Is your